Fireman Sam and the Faulty Electrics. It was the end of June. Trevor Evans had taken Dilys Price to watch Glamorgan in a county cricket match. They had returned to her grocery shop come house in the bus he was paid to drive. Norman had been left home alone. As Dilys inserted the key into the lock, she heard the faint sound of sobbing coming from the kitchen come diner. "Ma'am, I think a fuse has blown," wailed Norman inconsolably. "I put the kettle on, and the whee, and the trouser press, and the dishwasher, and the lava lamp, and I was charging my bedside light and my phone." "That's a lot of electrical items," stated Trevor numerically. After a little while, Fireman Sam found himself carrying out tests on all the wiring and electrics in the building. "Cowboys," he muttered irritatedly under his breath. Inspection having been completed, Fireman Sam had concerns. "Who did the electrics here?" he asked Dilys. "Mike Flood, the accident-prone handyman," she replied. "Well," started Sam, "he hasn't done a very good job. In the past he's fixed up a few houses, 20 jobs in each, with a 15% chance of a fault for each one. This house has 5 major faults." "So he used to make 3 mistakes on average, and now on this one he's made 5, calculated Trevor. Has he gotten worse?" "It's difficult to say," Sam responded. "I guess we'd have to perform a hypothesis test." Sam perambulated to the selection of newspapers and magazines and took out the Pearson Edexcel formula book, which was being given away as a free insert with the local rag. He sat down with Dilys, Trevor and Norman and explained how hypothesis testing worked. "Firstly, we need an hypothesis, such as Mike Flood is making more mistakes than he used to, and we need to select an appropriate statistical model, which in this case would be the binomial XB20 0.15. We need a null hypothesis, which would be H0 p equals 0.15, and an alternative hypothesis, which would be H1 p is greater than 0.15. The situation we're testing is that Mr. Flood has made 5 mistakes, so we look at the probability of 5 or more." "Why 5 or more and not just 5?" asked Norman. You just do okay," Sam stuttered. 5 or more is the opposite of 4 or fewer, so that's 1 take 0.8298, which is 0.1702. "So what do you do with that?" asked Trevor. "You need to choose a significance level, which very often is stated as 5%. Comparing our answer, we see that 17.02% is more than 5%, so it's not unlikely enough to raise suspicion. We say that it's insignificant, we reject the alternative hypothesis, and we state that there is no evidence that Mike Flood is making more mistakes than he used to." "So we were just unlucky," pondered Dilys. "How many mistakes would he have had to have made for it to be significant?" "Well, that would bring us into the realm of critical regions," answered Sam, "stating in advance under what conditions you would consider a suspicion to be justified. Looking at the table, it would be x is greater or equal to 7, because 1 take x is less than or equal to 5 is 0.0673, which is still greater than 5%, whereas 1 take probability of x being less than or equal to 6 is 0.0219, which isn't. When I was at school, there was a thing called a two-tailed test," recalled Trevor. "What was that all about?" "Sometimes you need to check if something is different rather than just higher or lower," replied Sam. "If you're aiming for a 5% significance level, split that in half to make 2.5%, and then get as close as you can to 2.5% at the top, x equals 0, probability 3.88%, and as close as possible to 2.5% at the bottom, x is greater or equal to 7, probability 2.19%. Finally, you can work out the actual significance level by adding 3.88 and 2.19, which gives 6.07%. And so, despite the potential death trap that was the grocery shop, Mike Flood was permitted to continue causing havoc on circuit boards throughout Pontypandy.